Hello, this is Mr. Huff, and I want to talk about the different phases or stages that a star goes through from its birth until it ceases to be a star anymore. All right, so let's start with the low mass stars. We start in the interstellar cloud, and this is just a cloud of gas and dust and just various stuff floating around. It's very large. At this point, there is nothing, no source of energy. It's just stuff floating around. What happens is, by gravitational attraction, we end up with matter starting to collect together. And when that matter is collecting together, as the mass concentrates, the temperature increases. And we have a protostar, so the energy source at this point is gravitational attraction. Once it gets enough mass together and the temperature gets high enough, it shifts from being a protostar to a main sequence star. And a star becomes a main sequence star when it is born, and that happens when hydrogen fusion begins. So that's the source of energy for the main sequence star, is hydrogen fusion. And as it uses up its fuel, it reaches a point where the center collapses and the outside expands, and it turns into a red giant. The first red giant phase is hydrogen fusion still. But eventually that will run out of energy. And then it shifts to a yellow giant, and yellow giants shift from fusing hydrogen to fusing helium. And as it will remain a yellow giant for a while, and when that fuel starts to run out, it will do the same thing as the main sequence did. So it'll turn into the second red giant phase, but in this case, it's only helium fusion going on in there. And then when that runs out of fuel, the outside of the star just expands and it sends material out into the universe. And we're left with this dense, hot core. This is a white dwarf, and that's also when it makes the planetary nebula. And once this planetary nebula disperses, we're left with a white dwarf. In these phases, the only energy source is the remnants of thermal energy, and eventually the white dwarf will run out of thermal energy and just be a black dwarf. So that's the low mass star. Let's look at the high mass star. The beginning phases are exactly the same, but in this case we have a lot more mass involved, so there's no energy source here. We have gravitational contraction here that causes the star to be born and generate a lot of energy. So what's going on is, as that center collapses, as that mass gathers, temperatures increase. It eventually reaches a point where hydrogen fusion starts taking place, and at this point it's a massive main sequence star. It's a little different on this one. As it runs out of hydrogen fuel, it goes through several iterations, and in our diagram here it only shows the pulsating yellow giant and then the red giant. But what's going on here is it starts by fusing first of all helium, and then it fuses, then it expands and contracts and goes through that cycle again, but it shifts from helium fusion to carbon fusion, and then carbon fusion to neon fusion, and then toward the end of its life we're going from neon fusion to oxygen fusion to silicon fusion, and silicon fusion ends up resulting in iron fusion. The transition from silicon to iron, that process generally takes about a day. It's extremely fast. And iron absorbs the energy instead of releasing it like the previous phases, so the red giant collapses in on itself, and we have a supernova. The main energy here is that gravitational contraction. When it collapses, it also causes a shock wave to go out, and it sends out this cloud of elements into space. This is an extremely powerful event, and this material moving through an interstellar cloud, it's actually moving fast enough that it can trigger the birth of new stars. Okay, so once the supernova occurs, we're left with one of two fates depending on the mass. It will either become a neutron star or it will become a black hole. The more massive it is, the more likely it's going to become a black hole. So that is an overview of the phases of the stars, thinking about what the source of energy is.